Here we have been able to balance the equation. 14 hydrogen, 2 times 7, 14. Oxygen, 7. 7 oxygen. So everything is chromium 2, 2 chromium. So they are all balanced. Okay, hello and welcome. Let's look at something like this. Balancing of reduction oxidation equation. Reduction oxidation equation. So we are not going to just do one. I will teach you two, so that at least you'll be able to answer the questions. See, the question says, many of you, the subscribers, requested that this be done, and I decided that I have to do it. So whatever you tell me to do, I will make all efforts to do it. So this is what I'm doing now. So join us. If you have not subscribed, you can subscribe and keep following us. So write a balanced redox equation between potassium heptaoxodichromate 6 and iron 2 tetrasulfate 6. Now let's solve this very quickly. Now let us recap. What is an oxidizing agent? An oxidizing agent is that substance that increases what? Increases what? Oxidation state of another what? Substance. This agent will increase oxidation state of another substance. When the agent increases oxidation state of another substance, the agent itself will get what? Will become what? Reduced. When it increases oxidation state of another substance, itself it will get reduced. So an oxidizing agent is that substance that gets reduced. Don't be confused. Agent gets reduced. Oxidizing agent. If it is reducing agent, it is that substance that reduces oxidation state of another substance. So when it reduces oxidation state, which is the charge, itself it will become what? Increased, oxidized, it will become increased. I hope you can understand that. So let's look at that now. And in our previous videos, we have mentioned oxidizing agents. Look at oxidizing agents we have. K2Cr2O7, that is potassium tetraoxodichromate 6, KMnO4, oxygen, and the rest of them. We mentioned all of them, HNO3 and other oxidizing agents. So now, but this question talks about potassium heptaoxodichromate 6. So this is it. So now this is the oxidation part of it. This. So we have, look at it, Cr2O7. What is the charge? 2 minus. Now, heptaoxodichromate 6 ion. Heptaoxodichromate 6. It is 6 here. So this is an oxidizing agent. It will become reduced. It gets reduced. Now, let's call it reduction half. You call it reduction half. Let me clean this. Reduction half, because this oxidizing agent will undergo reduction. It will become reduced to Cr3 from 6 to 3. So this is balanced like this. From heptaoxodichromate 6, I solved this thing, the oxidation to determine it in our previous video. Please go and check that. Heptaoxodichromate 6, this is dichromate 6. Then this one is what? From 6 to 3, so it has been reduced. Now, what I do tell students is this. Just be careful. This side we have water, and you add the appropriate number of hydrogen ion here. Water, this is oxygen. So you add oxygen here with H2O. Look at what we are going to do now. Cr2O7 2 minus. Then let's be like this. 2 Cr3 plus H2O. Having something like this now. Now check. How many oxygen? Look at this. So it is very, very simple. Follow me very well now. How many? Look at, you have seen what I did. You must take note of this information. This heptaoxodichromate 6, I showed students this orange. When it undergoes reduction, it comes to this. This is green. From orange to green. Orange to green information. So if you are performing an experiment or practical, if you observe something orange to green, it means that it has come in contact with a reducing agent, or it has been able to reduce another substance. To oxidize rather. It has been able to oxidize another substance. And when it oxidizes another substance, it becomes what? Reduced. Now, this is 7 oxygen here. 7 oxygen. Oxygen is here. So you write 7 here. So how many hydrogen do you have here? 2 times 7, 14, right? Plus 14 hydrogen ion. Now, look at it now. Put ion here. What the next thing you have to do is to count your charges at both left hand side and right hand side. Now look at it. This is minus 2 plus 14. What is total charges here? Plus 14 is what? 12. 14 minus 2 is 12. Now 2 times 3 is what? 6. This is where we are going to now do something. This one is how many? 12. This one is what? 6. So it's not balanced. So you can balance it. This is plus 12. This one is plus 6. To balance it, you have to add electron. Electron is negatively charged. So this one is having SS6. So if I say plus 6 electron here, that is 12. Electron is minus. Just like saying 12 minus 6. Electron is minus. 12 minus 6 will not make it 6. So what I'm going to do here, I'll add electron. Electron is negatively charged. If I add 6 electron here, it will balance it. 12 protons. If I add 6 electron, it will reduce it to 6. So it will become 6 plus 6 and plus 6. So this is what I'm going to do now. So I'm going to write plus 6 here. So let's continue it here. Cr2O72 minus plus 14 hydrogen ion, then plus 6 electrons gives us what? 2Cr3 plus 7H2O. Let's still confirm it. 2 minus 2 plus 14 is what? 12. 12, this electron is negative. 12 minus 6 is 6 plus 6. Now 2 times 3, 6. So it is balanced now. This reduction half is balanced. After this one, I'm going to do another one with tetrazole manganese 7. I'm going to do another one now. So pay attention. Alright, so now we have finished this one. So let's go to oxidation half. Oxidation half. In this oxidation half, ion 2, tetrasulfate 6, we undergo oxidation to ion what? 3 ion. From ion 2 to ion 3. Oxidation. So now, look at this. The color of this is green. So if it undergoes oxidation, let me just say if it's ion 2 chloride, it's green. So if it undergoes oxidation, it turns reddish brown. So anytime you observe reddish brown, anytime you observe anything reddish brown, it means that it has turned from ion 2 to ion 3 ion. Rust. Ion 2 oxide to what? Ion 3 oxide. Some of you will be asked, is this ion 3? Yes. The charge here is 3, 2. So this 3 comes here, 2 comes here. Check one of the previous videos where I taught oxidation and the balancing of chemical equations. And I'm still going to do it again anyway. So now when you check, you have 2 plus here, you have 3 plus. This one plus 2, here plus 3. So the charges here are more. So this is where you add electron. So if I put 1 minus 1, it will balance with this. So I need to put 1 electron here. If I put 1 electron, it becomes 3 minus 1, 2. So it will balance. So what I need to do here is electron. So I've balanced this side. So 2 here, 3 minus 1. Electron is always minus 1. 3 minus 1 is 2. Alright. So now, because we have 6 electrons here, we can ordinarily put 6 here, put 6 here, put 6 here, so that you can combine the whole of this left hand side and the whole of this right hand side. You can cancel out. So combining the two, we have Cr2O72 minus plus 14H plus 6 electrons. Well, then this is plus 6Fe 2 plus. Now gives us product side 2Cr3 plus 7H2O plus, right, 6Fe3 plus 6 electrons. So 6 electrons here, 6 electrons. This can cancel this. Then we'll bring them together. So let me try to see how I can manage it to be in straight line. 7,2 minus plus 14H plus 6Fe2 plus gives us 2Cr3 plus 7H2O. Let me put this ion first before H2O. I will have put this one before, but it's the same thing. 6Fe3 plus 7H2O. Let's count it. 14 minus 2 is 12. Right? Then this one, 6 times this one is what? 12. So 12 plus 12, 24. Let's check this one as well. 2 times 3, 6. 6 times 3, 18. 6 plus 18 is also what? 24. So it's balanced. Minus 2 plus 14, 12. This is 12. Then 6 times 2, 12, 24. 2 times 3, 6. 6 times 3, 18. 24, 24. It is balanced like this. There is no mistake, no error. So here we have been able to balance the equation. 14 hydrogen, 2 times 7, 14. Oxygen, 7. 7 oxygen. So everything is chromium, 2. 2 chromium. So they are all balanced. There is no, so it's very well balanced. So after this, let's look at another one. Let's look at another one. We can also use iron 2, tetrasulfate 6, iron 2 chloride, and potassium tetraoxide manganese 7. Alright. Okay, let's do very quickly. So we have potassium tetraoxide manganese 7 and iron 2. See it. So this is now. So we have Mn, KMnO4 plus FeSO4. These two and these two. So let's be sure of this. Let's balance these two. This is the one that will undergo. This was oxidation, so it will undergo reduction. This is a reducing agent, so it will undergo oxidation. So let's start with reduction half. Reduction half. So look at it. MnO4 minus will undergo reduction to Mn2 plus. Tetraoxide manganese 7. I've taught this before. Plus what? This one will give us what? Manganese 2 ion. This is purple. This is colorless. Purple to colorless. Purple to colorless. Mind you that. So the normal thing, oxygen is 4. So we have to add oxygen here with as in form of water. So write MnO4 minus gives us Mn2 plus plus H2O. 4 oxygen. So we can put 4 here to balance it. As we have 4 here, it means that 8 hydrogen. We now write plus 8H plus. 8H plus here. 8 hydrogen ion. So when you count here, see 1 minus 1 plus 8 is 7. Plus 7. This one is 2. Okay, remember what I said in the last video. So as we have 7 and 2, the only thing you have to do you have to reduce this one by 5. So you add 5 electrons here. If you add 5 electrons here, it will bring it to what? 2. So let's do it there. So we have MnO4 minus plus 8H plus 5 electron gives us Mn2 plus 4H2O. So let's check. Minus 1 plus 8 is 7. 7 plus 5, 2. So it's balanced with this one. So let's move to oxidation half very quickly. Fe2 plus will oxidize to Fe3 plus. This is 2 as we did it before. Add 1 electron here. 2 plus. This is now 3 minus 1. 2. Because we have 5 electrons here, we can add 5 here, 5 here, and 5 here in a very simple form. So we can put the two of them together. This is still the same as what we had. So we have MnO4 minus plus 8H plus let's bring this one 5Fe2 plus this 5 electron gives us Mn2 plus 4H2O plus 5Fe3 plus 5E. Now 5E, they can cancel out. The two of them can cancel out. So let's manage this space as well. MnO4 minus plus 8H plus 5Fe2 plus gives us Mn2 plus 4H2O. You can write this one before H2O. Let me write it like this. 5Fe3 plus 4H2O. Let's count. 1 minus 1 plus 8, 7. 5 times 2, 10. 7 plus 10, 17. This is 2. 5 times 3, 15. 15 plus 2, 17. So it's balanced. Or 4 oxygen, 8 hydrogen. This is also a balanced redox equation. Thank you very much. And I pray that, and I wish you'll be able to answer it anytime. Just know how the charges, the reduction will occur, and how the oxidation will occur. It's not a difficult thing. Thank you very much, Mr. Primus.